All right, so we're going to talk through sort of a example that's posted for you all in the lecture notes, under the processing notes. Again, you can get that by cloning my CSCI 1423 or going to GitLab and looking at my CSCI 1423, not yours. But you can pull down the blob fun. It's a zip file, but you can just extract it and move that folder either into your processing folder or run it directly from there. But it needs to stay inside a blob fun or inside of that blob fun folder. And you can just go to in processing file open, or if you extract the blob fun, assuming you've installed processing properly, you should be able to just open up the blob fun folder, double click on blobfun.pde, and it'll open the whole thing up. Now, an important thing to note is if you get the zip file, you have to extract the zip file. Just like with extracting a tar.gz file or anything else, you need to extract it in order to be able. You can't just double click on it. That just opens it. It's not all the pieces are open. You need to actually extract it by right clicking or using unarchive or 7-zip, whatever method you want. You need to extract that entire folder so you have all the pieces, and then you can work with it. Okay, so we've got blob fun open up here, and notice that there's two different tabs. Okay, and that's because blob fun is sort of the main program, and then blob is the secondary. That is a class. Okay, so a class is essentially the blueprint for an object. Well, it's an object. An object is you can think of it in processing being like a complex shape. So it's something that's it's not one of the predefined primitives like an integer or something like that. It's a chunk of code that operates as sort of its own entity. Okay, the class. So you have the class, which is the blueprint, and then you can create different objects based off of that same blueprint. The same way you sort of have the human genome, but there are different people, okay, all created based off of that same blueprint, okay, with various nuances and that sort of stuff. There are various variables that can get set whenever a new object of type human is created. So our objects are blobs. They're basically circles, but with some tweaks that we've added to them. Okay, and then blob fun is the program that's sort of running things. Okay, so we'll take a quick look at blob fun, and we'll switch over to blob, and then we'll switch back. So the first thing that we do in blob fun is we create new blobs. Now, note we're not saying int or bool or float because those are primitives. You don't have to do anything in order to create those. Now, I forgot up at the top, we do have, it's commented out, but it says import java.util.arrays. What you may find is that there are certain additional libraries that you want to import. Now, we don't really need arrays in this example, so I have it commented out. But this would also be like if you were trying to bring in sound.processing, this is where you put import java.util.sound.processing or whatever the import line is to bring in that additional library, that additional functionality. Okay, that's just an example. We aren't actually using arrays in here, so we don't need to do it. But if you're wanting to use arrays, you would need to include import java.util.arrays to work with it. Okay, now what we do there, we say blob1 equals new blob, and then empty parentheses. What that's saying is that we're creating our data type, okay, is a blob. That's essentially like saying, give me the space and memory to make a blob. I'm going to name it blob1. And what I want you to put in that space called blob1 is actually construct or build a brand new blob object based on the blueprint that is in the class file. Okay. And it's actually calling what's called the default constructor, which means we just say, hey, give me a stock blob. Okay. So if you just buy, a stock HP DB7 laptop, okay, you can just get whatever the stock one is, or you can customize it. So that's essentially what we're doing with the second line when we say blob2 equals new blob, and we pass things in. We're saying, again, the first blob says, that defines the data type, says, boom, give me space and memory to hold a blob. We're going to name it blob2, and what we're going to put in there is a new blob, but we don't want just a default one. We want to pass in, we want to put in these custom things, okay? And as we'll see in a bit, what I'm actually passing into that what's called an overloaded constructor, okay? So not the default constructor, but a secondary or customized constructor, are some integers, some hard numbers, and those are going to be to set the color of the blob from the beginning, okay? So You'll then see we have a setup method, we have a draw method. Setup method, fairly straightforward, just sets up the canvas. The draw method is kind of interesting. What the draw method actually does is it says, since at the very beginning we defined a new blob called blob1 and a new blob called blob2, those are now entities, okay? So that's like saying human Bob equals new human, and human Sally equals new human, and passing in red for the color of the hair, okay? And then where we have blob1.display, blob2.display, those are calling methods that are associated or capabilities of each of those objects, okay? And we have to call them independently because, for instance, in our human example, I can't say Bob jump and have Sally jump. I have to call each of them by name and call the method or the action that they should perform, okay? So in the case of blob1.display, that actually makes blob1 display, and blob2 display, that actually makes blob2 appear or be drawn onto the screen, okay? I then have a if mouse pressed method, okay? And basically with the mouse press, what that's doing is if the mouse is pressed, okay, then change a couple parameters, okay? And it actually calls these various methods called setters. And a setter is a method where you can basically, from whatever is calling it, you can reach in and say, hey, set this inside of you. So for instance, if I said, hey, Bob, your name is Bob, you are part of group B. Bob internally would know that he sets himself to be group B. And that's what a setter method does, is it just reaches in and changes the internal state of an object. Okay? It sets something inside of that object. A getter essentially gets something out of that object. So when I ask Bob what his name is, I'm like, hey, you, what's your name? And he says, oh, this is what I am. Or if I said, hey, Bob, what's your group? Bob tells me group B. That's essentially running a getter method to get information out of that object. Okay? And you'll notice that I'm calling all these different set methods. So when the mouse is pressed, it changes it, sets the color, it sets the size, it sets the location. It's basically changing where these blobs will appear, what their internal state of, hey, whenever I show up, this is where I should show up at. So it displays them in whatever the default was when they were constructed. And then when the mouse is pressed, it changes those settings. And you'll notice those are pretty long. We could have said like set size and then just passed in two constant numbers. But what I did in this example is I actually passed it, I generated random numbers. And it sort of looks a little confusing because this is doing method chaining. So essentially, you have to drill down, use PEMDAS, okay? And so there's the rand function, which generates a random number, okay? And if you look at the reference, you can see how that rand function works, okay? So you can set, like if you set an upper bound, it goes between 0 and that upper bound, or you can give it two numbers and it basically goes to your lower and your upper bound. It generates a random number in between those, but it generates a decimal number by default. So what we do is we wrap that inside of the int parentheses, and what that does is that generates a random decimal number, and then when we have that inside of int, that int method just cuts it off and converts that decimal number to an integer, and that's what we actually pass to the set color or the set size or set location. So you really want to read, again, as we talked about in the past, read from right to left. Or again, look at your innermost parentheses, just like in our order of operations. Perform the innermost set of parentheses, and then the result of that is passed to the next set of parentheses, and so on and so forth. Okay? And it may help to sort of play around with these to sort of get a feel for, if I change this, what does this do? If I change this, what does this do? Okay, and you've got blob1 and blob2 there, so you can see, okay, I can change this one, and this is how this is affected. If I change this, this is how this is affected. Okay? Now, I haven't commented out there a couple lines that are print lines that are getter methods. You don't need to use those, but if for some reason you needed to reach in and you're like, wait, what's the internal state of this object? You could have a getter method that essentially returned that, and then you could print that out or do whatever you want to with it. Now, those print statements, if they were uncommented, that would print out to that little console area within the processing IDE. Okay. What we're going to do now is we're going to switch over to the blob tab, and this is where the blueprint for blobs is. Okay. So it starts with class blob. Okay. So this defines what all a blob has and what a blob can do. Okay. Just with the human genome. Okay. So we start off with some, they're called fields, sometimes called class variables, but these are they're variables that they are independent to each object, just like your eye color, your name. Now, while you may have the same eye color as someone else's eye color doesn't affect, well, ignoring inheritance for the time being. You can get into that in programming too, more. But in general, just because I have hazel eyes doesn't mean you have hazel eyes, because those are fields or class variables that are tied to me as an individual instance of the human blueprint. Okay? And an individual instance is called an object. So we set a couple field variables, so location X, location Y, okay, or we make them available. And then what you'll notice is that we then have blob with empty parentheses. Okay, that's the default constructor. So if you think back on blob fun, and we can switch back to blob fun here. When we create a new blob 1, we said new blob empty parentheses, which means it reached in there and it called that default constructor. So we're switching that back to blob. It created blob 1 based on whatever is in that default constructor, whatever's within the curly braces for blob with empty parentheses. Below that is what's called an overloaded constructor, where we have blob and we actually take in things. That's our custom blob create constructor. And we take in things and we set them to the internal state. Okay, so you can see there that we have basically, for our overload constructor, blob takes in, was it R, G, and B? Mm-hmm. Okay, it takes in R, G, and B, and then we take those RGBs that were passed to us and we set them to our internal state. Okay, we set them to whatever our internal awareness, or that blob's internal awareness, is of its red, green, and blue state. Okay. Below that, we have various setter methods. So what's interesting about a setter method is you'll notice that your set methods start with void. Okay, and so it's void because they return nothing, because the setter method, you're passing something in, you're not returning something. So the return type is void, then the name of the method, and then in parentheses, the things that it takes in. What can you pass to it? Okay? Think about this being like a setter method is like the first window at McDonald's. Okay, so at McDonald's, basically, that's a setter window. You pass money in. You don't really get anything out, maybe a receipt, but you pass money in. Okay, your getter methods are the second window, where you actually get food. They return something out to you. Okay, so we have various set methods in order to be able to change the color, change the location, and change the size of our various blobs. Okay, within certain parameters. Okay, and that's what's defined between all of those curly braces. And then, of course, there's a getter method, which is our way. The getter methods, if you notice, they have a return type, so it's typically int. Okay. That basically says, hey, if for some reason I need to reach in and find the internal state of what is the internal state of blob 1 or the internal state of blob 2. The getter methods are my way of reaching in to find out what that is. Okay. Now, blob fun's a short enough program that you should be able to say, oh, hey, this is what I passed in, unless, of course, as this example has, we're doing it randomly. And if you weren't able to see it, getter methods are really useful for being able to say, okay, what's the internal state of this object? Okay? So for instance, if you looked at somebody and they sort of had a passive face, okay, you wouldn't be able to know how they were feeling unless you said, hey, how are you feeling? Okay, and they would say sad or happy or whatever. Okay, their return type is a string, okay, which evaluates to a specific emotion or what have you. Okay. So this is just a little blueprint of how you could create an object. And essentially, in this case, it's just drawing circles, but it's not just a plain circle. It's circles with specific, it's a circle with more added to it. An object, again, so like, for instance, you could draw a house by, in the draw method, defining the triangle, defining the square, defining all that sort of stuff. Or you could create a class called house, where all of that was defined within the blueprint, and you could just say, hey, give me a house. It would jump over to that chunk of code and generate a house for you automatically. And you can make multiple houses all based off of that same blueprint. Okay? If you've been in a lot of housing developments, you'll be around and say, hey, these are all cookie cutter houses. That's because they were all built off the same blueprint. Object-oriented programming, which is what this is you're orienting things around the idea of building objects. You define pieces of code so that you don't have to rewrite that code over and over and over again. Think of it as like creating subroutines, and again, subroutines, methods, they're the same thing. In Perl, they call them subroutines. In Java, they call them method. In Python, they call them functions. It's all the same thing. It's a named block of code. Okay? This is actually just grouping things together. Think of objects almost like modules, okay? Where it is actually a group of methods and state or variables bundled together that you can call on and say, boom, make me a new one of these, make me a new one of these. And it generates it that way. Okay? So let's go ahead and switch back to Blob Fun, since I've talked about this code a whole bunch. And let's go ahead and hit play. And so when you hit play, you'll see that you get your background, and there are two little blobs there. Actually, I don't know which one's blob 1 and which one's blob 2, but it doesn't really matter. One of them, if you keep running this again, you'll figure out which one's blob 1 because it'll always start in the same place. Okay. Or actually, I think blob 2 we passed in what color? 200, 0, or 255, 0, and 100. So that's sort of a pinkish color.
Yeah.
Okay, that blob 2 is the pinkish color one. Okay. The one that's not the pinkish color is going to be blob 1.
Okay. Blob 1.
Okay. That's blob 1, there's blob 2, okay? Now, it just keeps drawing them in their same location over and over and over again, okay? So this is sort of what we had in the first video where we just said, boom, draw that square in the same location over and over and over again. Where they appear on the screen does not change until we press the mouse button. So if you will, press the mouse button, okay? And press the mouse button again, and again, and again, and again, and again, and again, okay? Now, notice that it looks like it's making new blobs. It's not really making new blobs because we don't redraw the background in the draw method. It doesn't erase the ghost of the old location and color of the blob. So what's happening is you're seeing the ghost, and every time you press, those the same two blob 1 and blob 2s are just jumping around the screen, changing their size, changing their color. Okay? If we put something like, and we can actually make this change here in a bit. We'll actually just go ahead and do this. So let's stop the sketch. If we go ahead and go into the draw method, and at the very top, we write background, parentheses, 0, close parentheses, semicolon, and rerun the sketch, what you'll see is your blob 1 and blob 2 again. And when we click, and we keep clicking, should redraw the background over and over and over again. So you don't see the ghosts of where the blob 1 and blob 2 used to be and what they used to look like. You instead see, hey, this is their new state. And that's all generated based on that mouse press that where we have blob 1.set size, blob 2.set size, blob 1.set color, so on and so forth. When we press the mouse button, it performs all those actions, changing the internal state of each of those two objects so that they appear to jump around the screen. Okay? That's it as far as explaining this example goes. Again, there's tutorials that walk you through this process. You can look at other people's examples. Another interesting site to go to is Open Processing. I think it's openprocessing.org. But if you search for Open Processing, you'll see a bunch of different examples where people are doing complex and simple things. But again, based on this idea of objects allow you to say, boom, here is this complex structure that I can call on over and over and over and over again. So that's it for this example of Blob Fun, which demos, objects and how they can be used in processing. Okay? Make sure for your final project, you talk with other people, you ask questions. But before you talk to other people and ask questions, you should most definitely go to the reference page and read the documentation. That's the first place you go to. Okay? If you don't read the documentation and you're posting on the forum saying, how do I do this? A response you might get is RTFM, which is read the manual. Okay? You don't want to be the person that's constantly getting RTFM'd. Okay? Or if it's in Great Britain, RTBM. But read the documentation, dig through the code, dig through the examples. One of the nice things about the processing IDE is when you install it, you can actually go to File and actually look at some of their examples that they have that are downloaded automatically. So you don't even have to go to the processing.org website for those examples. You can actually, when you install processing, they're there for you. And you can look at the code, see how they run, and actually fiddle around with the code that they give you to say, oh, this does this, oh, this does this, to get a better feel for how that code is working. And that's what I strongly suggest you do, is read the documentation, take the sample code, get it running, and then fiddle with it. And then as you become familiar with that, that's when you start saying, okay, I'm going to actually sort of write my own code and do this way, or this way, or this way, or this way. But that's the pattern that you follow. This is your springboard into programming 2, because in programming 2, it's very much you are given a task, and it's a complex task, which you may understand some background knowledge of, but you don't understand exactly how it's supposed to be done. You have to go out, dig through the documentation, find the sample code, get the sample code working, tweak the sample code, and then you build your own from there. That's a pattern that you will follow over and over and over again, not only in programming 2, but as you go forward. Okay, so this final project is really sort of bridging you into programming 2. But read the documentation, play with the examples, work with your peers, and ask questions.